Hello children, we are doing class 12, chapter 3, current, electricity and extra questions based on physics. So, in the circuit shown in the figure, find the current through each resistor. They gave the resistances R1, we can name that one as R1 equal to 0.5 ohm, R2 1 ohm is the, and R3 4.5, R4 3 ohm and R5 6 ohm. So, we'll write that on. First, we will find out the total EMF. Here, one battery's direction. Batteries are reversed actually. Positive of one battery is connected to the positive of the other cell. Positive of one cell is connected to the positive of other cell. So, directional flow of current for the first cell is from positive to negative. That means from left to right. And directional flow of current for 8-volt battery is from right to left. Since the directions are opposite, we'll take the total EMF as the net EMF. So which one will decide the direction of flow of current? Which one is having the higher potential, higher voltage will decide the direction of flow of current. So direction of flow of current will be decided by 8-volt battery. So the total EMF or net EMF in that circuit will be equal to 8 minus 4. Equal to 4 volt, because the directions of flow of current are opposite in both the cells. Now here resistance R1 will take us 0.5 ohm, R2 to 4.5 ohm, R3 I am taking first, R3 as 1 ohm. Now R4 and R5 I will give, R4 equal to 3 ohm, R5 will be 6 ohm. Now here first this R4 and R5 are in parallel. So we have to find out the total resistance in the parallel combination. So total resistance. We'll write R4 and R5 are in parallel. We'll give the name R4. Now here R4 and R5 are in parallel. So R4 and R5 are in parallel. So 1 by R parallel or 4/5 mean, or 1 by R parallel equal to 1 by R4 plus 1 by R5 R parallel. So it will be equal to 1 by 3 plus 1 by 6. LCM of 3 and 6 will be 6 only. So 6. 3 into 2 is 6. So 1 into 2. And 6 into 1 is 6. So 1 into 1. So 2 into 1 is 2. Plus 1 into 1 is 1. Equal to 3 by 6. Which is equal to 1 by 2. Now I will do R parallel, or which is also equal to R45. Equal to, take the reciprocal, equal to 2 ohm. That is the effective resistance for this parallel combination. Now we will do R1, R2, RP and R3 are in series actually. R1, R2, R3 and RP are in series. So it will be R1 is 0.5 ohm, R2 is 4.5 ohm. Next one I will take RP we got as 2 ohm. Next one is R3 is 1 ohm. Now R1, R2, RP and R3 are in series. Therefore, R series, or I'll name that one as 1, 2, P and 3. That is R series enough. P and 3 will be equal to R1 plus R2 plus RP plus R3. That will be equal to 0.5 plus 4.5 plus 2 plus 1. 4.5 plus 0.5 is 5, 5 plus 3 is 8. So, total resistance will be 8 ohm. So, total resistance. So, that is R series or R we can write. It is equal to 8 ohm. Since you know total EMF or total potential, total EMF and the total resistance, we can find out the total current in the circuit. You can find out. You know the formula V equal to IR, or here epsilon equal to I into R. So we'll write that one as I will be equal to EMF divided by the resistance. So it will be epsilon divided by R. That is equal to R series we'll write. That is equal to 4 divided by 8, which is equal to 0.5, 1 by 2, which is equal to 0.5 ampere. This is the total current in the circuit. So current flowing through R1, R2 and R3 and R parallel are same. So current through R1 is 0.5 ohm. Comma 4.5 ohm and 1 ohm are same. That is R is 0.5 ampere, because all these resistors are in series. Now, total current through RP, that is RP is 2 ohm, R45. That is 2 ohm, RP equal to 2 ohm, is also 0.5 ampere, is also I equal to 0.5 ampere. Now here in this parallel connection, that current I will get divided. Current I, which is flowing through that parallel connection, will get divided into 2 parts. One current will name as I1 and the other current as I2. Resistance will be 3 ohm, and here resistance R4. R4 is 3 ohm and R5 is 6 ohm. Now, potential difference in parallel connection will be same. Since the potential difference across R4 and R5 are same because of parallel connection we'll write V4 equal to V5. So what is V for? Potential difference. V equal to IR. So here I1 into R4. So I1 into R4 is equal to I2 into R5. But now since the potential difference across R4 and R5 are same, because of the parallel connection in that one, V4 equal to V5. I have not written that one. So that is I1 R4 equal to I2 R5 according to Ohm's law. So I1 will be equal to I1 into R4 is actually 3 equal to I2. I2 into R5 is 6. But what is I2? I minus I1. So that will be equal to I minus I1 into 6 is 3I1. Separately we'll write because I2 equal to, why? Because a part of the current I1 will flow through 3 ohm resistance and remaining current I minus I1 will flow through 6 ohm resistance. So I2 equal to I minus I1. Now we'll open the bracket. It is 3I1 equal to 6I minus 6I1. We'll collect the terms. 3I1 minus 6I1 will collect to the other side plus 6I1 equal to 6I. So 9I1 equal to 6I. But we know that what is I? I is 0.5 ampere. So 6 into 0.5 ampere because I equal to 0.5 ampere. So it will be equal to I1 equal to 6 into 0.5 is 6 into 0.5 will be 3 divided by, otherwise 6 into 0.5 divided by 9. So it will be 3 by 9 which is equal to 1 by 3 ampere. That is the current I1 through 3 ohm resistor. Three ohm resistor is I1 equal to 1 by 3 ampere. Now you want to find out the current through 6 ohm resistor. Current through 6 ohm resistor will be current through 6 ohm resistor equal to, that is I2 equal to I minus I1. That is equal to, I is actually, I is 0.5 ampere minus 0.5 minus I1 is 1 by 3. 0.15 we can write as half also, half minus 1 by 3. So when you take the LCM will be 6. LCM of 2 and 3 will be 6. So 2 into 3 multiply 1 also with 3. 3 into 2 is 6, 1 into 2. So it will become 3 minus 2 by 6 which is equal to 1 by 6. Unit of current is ampere. So current through, therefore the current through 6 ohm resistor, current through 6 ohm resistor is I2 equal to 1 by 6 ampere. So we found the current I1 through 3 ohm resistance and I2 through 6 ohm resistance also. Now we found the current through all the resistors. Thank you, children.